home. Firstly, like whatever you're going to do at home is what you should mimic in your exams. But me, the multiple choice, the way I view it is I can guess. I've got a 25%. So I can guess these if time runs out. With the short answers, however, I can't guess these. Right? So it's either you know what you're doing there and you'll get your mark, you don't, you get 0, or you know what you're doing there, you can get 3 marks, you don't, and you don't. So there's no really way of getting any marks here other than you actually putting something down. Whereas with your multiple choice, if time runs out and you've got a minute left, worst case scenario, you could just guess every single one. And it's not the best option, obviously. I'm sure you guys would have avoided that, but I'm just saying I wouldn't start off with multiple choice just yet, unless you absolutely feel super confident and you feel like, yep, I'm ready and I know what I'm doing with everything. Then by all means, go ahead and do that. Okay, so we are going to start off with the short answers as well. All right, I'm going to start off with the short answer questions. We should be able to answer everything here except all the probability questions because that's the only topic we have not done. With the exception of Josh. Josh, you've got to come on to. You're going to stay on into this class, but I want you to do a secondary class, and at the end of our lesson, stay back for a second. I just want to let you know what day that's going to be, just so you can catch up on your trig. Because I'm actually going to do that this weekend. So, but anyways, question 11. Let's get started on something like this. All right, simplify. Square root of 32 minus square root of 18 plus square root of 2, worth 1 mark. These ones here, 32, is 16 times 2. 18 is square root of 9 times 2 plus root 2. Square root of 16, is 4 root 2. That becomes 3 root 2 plus root 2. 4 take away 3 is 1. 1 plus 1 is 2 root 2. Okay. Any questions there? No. Easy mark. Cool. All right. Question 12, like I said, you can't answer. Question 13, we should be able to answer. Does anyone know the relationship between sine 90 minus theta and something else?
Yeah.
Yes, say it.
The top is sine theta, the bottom is cos theta.
Correct. So, in other words, sine theta and cos theta are what we say complementary. That means their angles add to 90 degrees. If you want me to prove it real quick, imagine I had theta here. Let's call this A, let's call this B, and let's call this C. You know that sine theta is equal to opposite over hypotenuse, so A over C. Well, what would this angle be? Well, this angle would be 180 degrees minus 90 minus theta, right? And then when you simplify this, you end up with 180 take away 90, which is 90 take away theta. So that angle there is 90 take away theta. If I decided to do cos of that angle, cos of here, I realize that that's adjacent over hypotenuse. And look what you just proved. That A over C and A over C are the same, so therefore sine theta and cos 90 minus theta must be the same. Or, like I said, in other words, you just prove that sine and cos theta are complementary angles, which means their angles add up to 90 degrees. Theta plus 90 minus theta, the thetas will cancel, you just get 90. So cos equals sine, sine of 90 minus theta equals cos. What's sine over cos? That's 1 mark.
10.
And that's your second mark. Cool. Any questions? Okay. Let's do this. Cassandra, you said you've got an assessment task on functions. Might as well do this one then and see if you're able to execute this. The function y equals f of x is defined as follows. So f of x is equal to x take away 3 for any x that's smaller than or equal to -3. It is 2x plus 2 for between -3 and 0, and it is x squared for any x value that's greater than 0. Evaluate f of 2, f of -2, and f of -5. All right, Alessandro, f of 2. How do I sub that in?
It's 2 squared
2 squared, beautiful. F of -2.
is -2 squared.
No. Do you understand how to do these
Oh,
questions?
okay, yeah, my bad.
Wait, okay, yep.
2 times by 2, -2, sorry, plus 2.
Yes, correct. And then what about f of -5?
It's 2 minus 3. Oh, wait, sorry, -5 minus 3.
-5 minus 3. Perfect. And then this answer is 4. -4 plus 2 is -2. This answer is -8. And then pretty much all it's saying is go and add up each one. So therefore, answer is 4 plus -2 plus -8. That gives me -6. Right? Wait, 4? No. What? -2 minus... Yeah. 2 is 2. Minus 8 is -6. Yeah, it's right.
Yeah.
All right. Anyone not sure what we've just done for each one and why we've subbed it into each location like that? No, we're okay. Because remember, you're going to get this in your exam. There's no point of being shy about it now. All good? Okay. If we say so. So draw a sketch of this graph now. Now, Lissandra, the way I draw a sketch of this graph here is to not include the domain just yet. It's the best way, right? So don't include the domain. Just draw your graph. So what we're going to do is draw y equals x minus 3. We're going to draw y equals 2x plus 2. And we're going to draw y equals x squared, right? It's the best way to actually attempt this. Let's just draw it on blue. So there's your set of axes. Then y equals x minus 3. How would I draw that, Alessandro? What am I looking for?
Straight diagonal line there.
Yeah, but intercepts, good, right? You need intercepts. Otherwise, without your intercepts, you can't really do anything. But it is a straight line. Good job for realizing that. So when x is 0, y equals -3. When y is 0, x equals +3. Straight line. And then red, do the same thing. It's a straight line. X is 0, y is 2. Y is 0. When y is 0, it looks like this. Subtract 2, divide by 2, x equals -1. It'll look like that. And last, y equals x squared is a parabola. Hasn't moved anywhere. Okay. Happy with that? And you feel like you can do that as well, Alessandro? No problems, right?
Yeah. Wouldn't you have to do the domains for it?
Now you'll do the domain. So first, always do that. Don't ever try to draw it with the domain. You're going to stuff it up. So draw them individually. Forget the domains. Now, let's start off with the last one because it's probably the easier one. X squared. You only want it for x greater than or equal to 0. So look at your green line and draw it for anything greater than 0. There. So that's what you would draw. Then, for your red line, it's got to be between -3 and 0. Now, at x is 0, we know it's not including 0, right? So when I sub in x is 0, which I get is at 2, that's going to be an open circle. And what about at -3? How do I know where to stop? How do I know, like, that's -3 there, but how do I know if it's here or what do I know? What's the y value of that?
You'd use
What do I need to do
formula.
there? Yeah, you got to use the formula. So you got to actually
Is
Sub.
yeah.
X equals -3 into y equals 2x plus 2. So 2 times -3 is -6 plus 2 is actually -4. You see, so if you had drawn it there, you just drew that, that's at -3. It doesn't really work, right? So my -3 here is wrong. Not -3 there. -3 is more, let's just go somewhere there, and I'm just going to cheat a bit and go there. And that's the line there. You get that?
Yep.
That's at -4. Okay, and then I'm going to highlight that. So the only answer you're going to draw is all of that. And then technically you would have drawn this in pencil, of course, so you guys would have just rubbed this bit out. But the answers are so far, whatever I'm highlighting in yellow. And last is your x minus 3. X minus 3, anything below and less than or equal to -3. So at -3, what is it at this line? So again, you've got to sub it in. So on the side, y equals x minus 3, sub x equals -3. Well, that gets me -6. So I know at -3, this black line, somewhere down here, should have been at -6. And that's equal, because it said equal, right? Equal, less than or equal to. Equal, and then you'll draw your straight line. And that has an arrow because it goes on forever. And that, whatever I've drawn in yellow, is the answer. That's probably the worst, one of the worst bits that has been completed over the years by students. Say it again.
Would you sub in positive
Can
3?
you come closer to the mic? I can just barely hear you.
Would you sub in?
Okay, yeah,
Would you just
go
sub
ahead.
in positive 3, not -3?
Would I just sub in +3, not -3? No, because this is saying x is less than or equal to -3. That it's this
Okay.
black. So for the black line, which goes on forever, you know, this way to this way, I'm only going to sub in from -3 to the left.
Okay.
I'm not interested about any numbers from -3 to the right, because that's
Yeah.
not the black line. That's the red line now.
All right. Yeah.
And then anything from greater than 0 should not be the red line anymore. It's going to be the green line now. Does that make sense?
Yeah.
So the biggest tip I can give you guys, if you got to write this down. Tip 1, draw them individually. Do not worry about the domain. Tip 2, restrict it to the domain. What you've got to watch out for is what are the y values. So you've got to sub these values in to see what the y values are at each point. So here, when I subbed it into the red one, we saw the y value was -4. When I subbed it into the black one, we saw the y value was -6. So that's telling you where you should start, and then goes to the left. And there's only one little thing that I didn't really highlight, but I will highlight it here. This again, this is green. It's got to start from here. This is an open circle. This is a full circle. What do we think? Do another one? Should we do another one, you guys?
Yes, please.
Yes. So we pause, open one up, press OK. Do you want to just make them up, Eden? They can really be anything.
Okay.
Sorry.
What do you-
They can be
2x.
2 graphs, and they can be 3 graphs. It's up to you. 2.
Okay.
It doesn't. Oh,
2x.
and it doesn't have to be straight lines. It can be anything you like.
2x squared.
2x squared.
This domain as well.
I can do the domain for you. That's okay. Do you want to go another one? Maybe that.
Yes.
And then maybe another one? Or are you happy?
4 over x.
4 over x. Okay, perfect.
Yeah.
So you've done a parabola with an exponential and a hyperbola. Good
Yes.
stuff. All right, my domain, I'll just make it x less than 0, less than or equal to 0. I'll make this one from 0 all the way to 2. And then I'll make this one, of course, x is bigger than or equal to 2.
Okay.
All make sense?
Yes.
Okay, let's do this. Let's see. So same thing, we've got to draw our axis first and just completely ignore the domain. It's the best way. So draw y equals 2x squared. Well, that's just a parabola. Draw y equals 2 to the x. What is that? An exponential.
It's like exponential.
That will start from down here and then slowly rise up, cutting at 1.
Yes.
You agree with that?
Yes.
And last one, y equals 4 to the x. 4 on x, sorry. 4 on x looks like this. It's a hyperbola that hasn't been shifted. So a whole lot of stuff happening thanks to you. Okay, any questions? You guys, firstly on that. That's already 1 mark. Okay. Now, my trusty little yellow highlighter. Here we go. X is less than or equal to 0. Less than or equal to 0, that means it's this. So I would have rubbed out this if I could. And if I didn't, if I've drawn this in pen, then I would actually use a highlighter and highlight my answers. That's completely allowed. So if it's in pencil, then rub out. If it's in pen, then highlight. And that's a full circle because it's also less than or equal to 0. If I sub in 0 into here, it still gives me a y value of 0. You guys get that? So that's done. Any questions there?
Nope.
Okay. Then I've got to draw this one. This one I've got to draw from 0 to 2. All right. At 0, I know it's at 1, but it's going to be an open circle because not equal to 0. All right, so that's an open circle. 2 to the power of 0 is 1. Open circle. Now, where do I stop? How do I know where to stop, Eden?
Would you sub 2 in?
Right, you have to sub in 2. So you're meant to stop at 2. Sub in 2 into here. Sub x equals 2 into this, which becomes 2 to the power of 2, which is 4. So you're meant to stop at 4. Why am I drawing an open circle?
Because it's not equal to
Because it's not
2.
equal. Done. So you've got 1, you've got 2, you're 66% there. You've just got to draw it for your green and you're done. Here we go. And at 2. Again, I know it's a hyperbola, so I know it's definitely not this. Right? We know it's this bit. But again, at 2, it's saying 4 on x. I don't know where to start. I don't know where to stop. I don't know if it's up here. I don't get this. So confusing. But you just sub it in. Sub x equals 2 into this, which would give you 2. So your y value at 2 needs to be at 2, which looks like exactly as we've drawn it. So we've got a pretty good diagram, and that's it. That is the answer for this, for f of x. What do we think? A lot better? Lisa, does this all make sense? Josh,
Yeah.
all good as well? I know you can't talk, you're probably just going to write it up, but all good. Everybody, Lissandra, feel good about it?
Yep.
Okay. Vinesh, did that make sense as well? Rather than Tiana. Vinesh, can you hear me? All right, let's get back onto this then. Okay. Amelia tosses. No, that's not for you guys. That's probability. Okay. Find the equation of the axis of symmetry of the parabola y equals x squared and the minimum value of this expression. Okay. I remember axis of symmetry. How do we find it?
Yes. Negative b over 2a.
I can't give that to you. You're missing something in front of it. I'm just being very particular now. Last term, I
A
would've said-
equals negative b over 2a.
say it again.
Axis of symmetry equals negative b over 2a.
I would give you that a little bit closer. I just want it a little bit more precise. Okay, what letter? X or Y? Your axis of symmetry
X.
is X. Yes, done. Because it's an axis, which means it's an equation. Oh, there it is. Find the equation. If you just write negative b over 2a, you're not going to get marks. It's going to be
Okay.
x equals negative b over 2a, which equals negative 4 on 2 times a, which is 1. 4 over 2 is 2. Done. X equals 2. And the minimum value, what does that mean? What does the minimum value mean?
If it's a positive parabola, then the lowest, like where the axis of symmetry is, like vertex.
You made it hard for yourself. It's just the vertex, exactly right. So it's just saying, once you found your 2, go ahead and sub it in. 2 squared is 4. 4 take away 8 is negative 4, negative 5. I think it's negative 13. Wait, what? Whoa, what did I, into 4. 4 take away 8, negative 5. So that's negative 4 take away 5 is negative 9. Are you seeing how easy these questions are going to be, Eden? You see how you don't need
Yes.
those questions that you've been trying to do and complete and stuff. It's just you just got to keep doing exams. The more you do more exams, you'll realize what questions are tested. You will. Question 17 looks very familiar. Isla observes a cliff from her boat at position C. She then sails 500 meters closer to the cliff to position D. The angle of elevation of the cliff top from C is 5 degrees and from D is 8 degrees. Find angle CBD. Find this. Any ideas? It's a lot easier than you might think. Can anyone see how to find that angle there?
Do we subtract 8 from 180 and then angle sum of a triangle?
172 plus 5 is 179. 179
That's
angle
1.
CBD equals 1 degree. Nice and small. Good job. Use the sine rule to calculate BD to the nearest meter. I like to just label it as X. Use the sine rule, so definitely already giving you the clue. You just found this is 1 degree, so you're going to use 1 with 500 and X with 5. Oh, could it be any easier? X on sine 5 degrees equals 500 on sine 1 degree. Can we please get the answer to the nearest meter? What'd you get? I got 2,497 meters.
Yeah.
Yep, cool. Anyone not able to get that? Hence or otherwise, find AD, correct to the nearest meter. So we're going to call that Y. Find Y. Hence or otherwise, well, we just found X, which now is 2,497. All right, any ideas on how to find Y? Any ideas, you guys? Lisa, any idea on how to find Y? It would be right, whatever you would say. 2,497, 8 degrees, and you've got Y here. And
Are we
it's a
just
right,
using Sakatawa?
correct. And which one would you use?
Sorry, I got a headache.
Try your best.
H
H and
A cos.
oh, good. See, you got it out though. Cos 8 degrees equals adjacent over hypotenuse. Easy question, right? Just multiply it over. You're done. I did say whatever you would say is right. 2, 4 cos 8. The nearest meter. I just want to see something. 73. 2,497 cos 8. Yeah, 2,473 meters. Again, if you didn't write this one to the nearest meter, you actually would lose, you'll get 0. So if you just wrote 2,472 point whatever, or just 2,472, unfortunately, you would actually get 0, even though you did everything else right. Only because it's worth 1 mark. If it was worth 2, you would obviously get 1 out of 2. Will 100% be in your exam? Lisa, Eden, Lissandra, Josh, I think you guys get it. It will, 100%. Exactly that. Give or take, I mean, they might change B to Bob and whatever, but it's essentially this style of question that will be asked. As a basic trick to know that you guys can do your sine rule, cosine rule, and whatever. Then a second one would be probably involving bearings. Okay. Any questions?
That's good.
Is that Rad? Rad here? No. Who was that? I can hear someone. All the values of X. Okay, go ahead and try that for me. Don't forget your all stations to central. And then Josh, maybe a good one to learn. We're about to do it in a sec. You'll see how I do this now. All right. Have we got some answers? Lisa, were you able to get an answer out for that one?
Yeah.
Nice. What'd you get? Let's see if you're right.
Theta equals 30 and 100. No. 3. Wait. Okay, hang on.
I think it's 180 plus 30 then.
Yeah.
So 210.
210.
Yeah.
And what is your teacher told you about degrees and radians? Or
They taught us,
Yeah.
like, mine told us how to go from radians to degrees and degrees to radians. Like how to
Yeah,
convert
divide
between-
it.
Yeah, that's
Divide
easy.
by
We've
180.
80 and put a pi.
Yeah.
Yeah, that's fine. We've done that. What I'm trying to say is, what have they said in terms of like some teachers that I'm seeing are doing this. So from the get-go, they're not writing 30 degrees. They're just writing pi on 6 first, and then they're doing everything in radians. Are your teachers okay to just convert it right at the end?
Yeah.
Yeah,
My
good.
teacher does that.
Good. Then that's
Yeah,
perfect.
mine too.
And we're happy. We're on the same page for once. Ah, x equals inverse tan. 1 on root 3. Inverse tan 1 on root 3. So that becomes, I'm assuming what you just said. I'll double check. It is 30. And then, of course, all stations to central. Nothing too amazing. It's just positive. So 210. And then, of course, if you divide by 180 and put a pi. So the first one should be pi on 6. And the other one is 7 pi on 6. So Josh, just so you can learn this real quick from just a 2-second perspective, you just obviously want to get rid of tan, so you're going to shift tan or inverse tan. Your first answer you get is 30 degrees, and then you've just got to work out where is tan positive. Tan is positive in this region here, which is 180 plus x, or 180 plus theta. So 180 degrees plus 30, which is 210. And then that's good, because the question says write it from 0 to 360 degrees. But if you want it in radian form, then you would divide by 180 and then put a pi on the top. So 30 divided by 180 is 1 on 6, and just put a pi on the top. And same thing with this. 210 divided by 180 is 7 over 6, and then you just put a pi on the top. Cool. Anyways, like I said, we're going to do it anyways. Don't have to stress too much. All right, question 19. What do I multiply by? I think last week you guys got this one wrong. So hopefully this week you can get it right. So
It's 2.
what do we multiply?
Okay. It is 2 plus the root 3 over 2 plus root 3.
Good. You see how you did one exam, you failed. Second exam, you didn't fail. Third exam, you might fail again. And the fourth exam, you actually remember it for the rest of your life. And it's okay. Like, that's the idea of doing exams. You'll start seeing the repetition in questions, but good job. You don't multiply by the same thing. You only do that if it was 1/3. If there is a minus or a subtraction sign, you have to multiply by the opposite. So you multiply the conjugate, which is a plus in this case. If it's a minus, if it was a plus, this would be a minus. Okay, 2 times 2, 4. 2 times root 3, 2 root 3. The bottom is 2 times 2 is 4. And then you could expand it, but I can promise you the middle section will just cancel out. So it's just root 3 times root 3, which is 3. And then the answer is, of course, 4 plus 2 root 3. And then the question says, pretty much find the integers a and b such that this, which is what you just did, is equal to a plus root b. So 4 plus 2 root 3 must look like a plus root b. I think we know what a is. It's just what b is. That's important. Any ideas?
Root 12.
Close, close. See, and I hope you remember what I'm about to tell you now. Because see, if you got that in an exam, you're so close, you're going to come back to me after the paper and say, Sam, was a silly mistake. And then hopefully we can avoid it now, so you don't come back after and say, Sam, was a silly mistake. Like, I remembered what you said. I didn't make the mistake. It is a root, Lissandra. So when you're saying this is the same as this, the idea is when you convert this to what you just said, the roots are the same. So what does b just equal to?
12.
Yeah, a lot of students write root 12s. So don't worry, but I hope now I've cleared that up. Root 12. You want to see when it would change? And obviously a is 4. Let me show you. If this question said this equals to a plus, what does b equal to now?
Root 12.
Yeah, because look at it. A is 4 plus, and then this is b. This whole thing is b. So now b is root 12. Good job. Lissandra, makes sense, yeah? Wait,
Yeah, makes sense. Yeah.
Eden, what were we saying?
But if b was just without the root, could we
But
put
if
2 root 3 as well?
not, oh, yes. Yes, sorry, of course. So if this was not here, yeah, you could have written 2 root 3, of course. Yep.
Yep.
Yeah, that doesn't make a difference. Yep. Yeah. And another version, obviously, would be the C root B. Obviously, C is 2 and B is 3. All right. So the best way I look at it is just look at it exactly. Like I compare it literally the exact same thing. So if the square root's there and the square root's there, well, I completely ignore the square root. And then B would just be 3 in this case. Good. That's a silly mistake saved. So be careful. And thank you for answering, so I'll know. So now you know what you would have said. If I had just given you the answer, you guys would have just written, oh, yeah, B is 12. And then we would have never had this conversation. So it's good. Say your answer. Say what you're thinking. Question 20. Make neat sketches of the following equations on separate sets of axes. Mark clearly the essential features of each graph. Essential features are usually intercepts. Intercepts, and then if there are any asymptotes. But usually intercepts for most questions. Okay, the 2 doesn't really do much to you guys. It's more about the negative x squared plus 2. I think we all know that by now. Sad parabola, shift it up 2. If I wanted to find the y-intercept, I would have subbed in x is 0. You obviously get y equals 2, which you already know. The other way around, if I made y equals to 0, I would end up with this. And then I'll start solving it. I'll bring this guy over and then divide by 2. And then x equals 2 plus minus 1. Now you got yourself full marks. Or you got yourself 1 mark in this case. Any questions? Two to the x, take away 1. 2 to the x is this, and it's got an asymptote there. So if I've got 2 to the x, take away 1, my new asymptote is going to be at -1. I was cutting here at 1, but if I'm going to shift it down 1, it's going to cut at
0.
Again, you didn't have to. If you didn't know stuff, it's not an issue. Just sub it in, right? That's how I did it when we did logs and exponentials. I showed you guys subbing in 0, subbing in -1, subbing in +1. If you subbed in -1, it would have given you a number here. If you subbed in 0, it would have given you here. Subbed in 1, it would have given you here. And then I'm sure you would have realized the graph. It's not a problem. The only problem is if you get 0. Don't try to get 0. Try to do whatever you can, especially for your graphs, to just test a few points and get it all out. Get yourself the 1. Okay, good. How are we feeling so far? We've done a few questions. Hopefully we're seeing, hey, these are not going to be too bad. No, that's not for you guys just yet. And hopefully you're realizing, hey, I can actually do this. I can do really well. I can see what Sam keeps saying, we can do really well. Because by the time you come to your prelim exams that combine all your topics, they just ask a little bit about everything. So they should be a lot better than your assessments. Express as a fraction in its simplest form. It's all about the denominator, right? So common denominator. So the way I do this is something like that. This times 9, this times 5, and then these two multiply together. So it'll look like this. Worth 2 marks. Here we go. 9x, take away 9, minus 10x plus 15 over 45. 9 take away 10 is -1x, so negative x. -9 plus 15. -9 plus 15 is 6 on 45. I got myself some good 2 marks. Any questions there? Okay. I just realized I didn't actually go through sectors in trig, which I will go through. But the reason why I also don't teach it is because I don't see why we should teach it. It is just year 9 and 10. For some weird reason in year 11 and 12, they decide to introduce a new formula, which I don't personally like to teach, to confuse everybody. And I don't really do it that way. So I'll just go, well, how did we answer these questions? Let's start with you, Lysandra, for example. Have you done areas of sectors at school yet? This year? Lysandra, can you hear me?
Sorry.
Yep.
No, we haven't done this.
There's a lot of background noise. I can't hear you. There's a lot of static. Sorry.
No, we haven't done it yet.
Okay, perfect. So then you would be the best candidate for this. Area of a sector, which is obviously part of a circle, right?
Yes.
So what's the area of a circle?
Pi r squared.
Good. But imagine it's not a whole circle. If it's only 50 degrees, what do you usually multiply that by?
360. Oh, 50 on 360.
See? And then obviously radius is 6. You're done. Look, that's why I don't teach it. Because I feel like we still know all this from I don't know, year 9, year 10, right, Lysandra, whenever we learned this.
Yeah.
But in year 11, what they try to do is introduce a new formula called half r squared theta, where theta is in radians. Now, my question is, why? Why are we doing this? You get the same answer. If you guys want to see it, just done. I'll show it to you. Half times r squared, 6 squared, times theta. Theta is in radians, right? So if you had 50 degrees, you've got to divide that by 180 and put a pi. So it becomes 50 pi on 180. And then if you want to see it, just expand it. 6 squared times 50. I'll leave it like that, actually. On 2 times 180 is 360. Now watch this one. 50 is there, pi is there, 6 squared is there, and 360 is there. So why should I go confuse you guys, create you a new formula, show you, hey, you can do this now with radians, but why? Why do that to yourself? I never learnt it, so why should you learn it? You don't need it. Just learn degrees, you already know it, it's done. It's easy. So please, when your teachers teach this, just you got to block that out because you don't need it. You're about to learn something you actually don't need. You can just use your basic, I don't know, area of a circle and circumference formulas. Cool. Nearest square centimeter. I think Eden and stuff. You guys are doing trig at school, aren't you?
Yeah, we just learned about what's it called?
Half r squared theta. This one here.
No,
Okay, good.
like we just learned, like just today we just we just learned all the like trig equation stuff.
All stations to central kind of thing.
No, the sine theta
Oh,
equals
yes.
cos
Yep.
90
Yep.
minus theta.
Yes. Or the
I just
identity.
finished trig, and we don't
Okay.
learn that.
You haven't. Well, you are meant to learn. That is part of the syllabus. So,
We're just about to start calculus.
well, your teacher missed it as well, but that's okay. That is meant to be there. But like I said, I don't really teach that. I just do it like this, like you just did, like Lysandra just did, without even knowing trig. He was able to answer this. It's not a problem. Don't complicate it. But definitely in the year 11 syllabus. Okay. Lengths, gradients, equations. Let's do it. All right. Also from last year, the points A, but these formulas are given to you. which is why I also didn't teach it, because we just did it all last year, and I don't think it's anything to worry about too much. The points A, B, C are plotted on a number plane. The point D lies on the y-axis such that AB is parallel to CD. Find the length of AB. All right, well, I'll give you the formula because, like I said, you're given the formula in your exam. Okay. And then, of course, what do we do? Lisa, what would you do here?
Sub in.
X1 and X2 and Y1, Y2, right? So just tell me, with 6 and 4, how would you label it? X1, and then what would this be?
Y1.
Yeah, good. That's all. I just wanted to make sure we know that. And then that's it, really. Just sub it in. Easy. Find the gradient. That's also given to you guys. But does anyone actually, has anyone memorized it? Starts with Y.
Y minus Y1 equals M X
Ooh,
minus X1.
I like that one. I love that one. That's my favorite, right? But that's only for an equation, just so you learn it. Equation of a line.
Well, then I don't know it.
Like, you see this one here? Look at, read C. Show that the equation of AB is this. You need the one that you just said. You know, you're about to start calculus, and in calculus, if you remember, we did tangents and normals. And to find tangents and normals, you needed equations of lines, y minus 1. So what you've just said is absolutely going to be asked, but that's to find the equation. It's important to know that. But yeah, gradient, you can use calculus, of course, but that's if you're given the equation. You're not given the equation, you're given points. So the formula is just y1 minus y2 on x1 minus x2. And then again, you just sub it in. Y1 minus y2 over x1 minus x2. Easy. Y1 minus y2 over x1 minus x2. 6 over 4. 6 over 4 is 1.5, so 3 over 2. And then show the equation of AB is this. Well, Lisa, why not do it together? You know what M is? M is 3 over 2. What's x1 and y? You can pick. What's x1, y1?
2 and minus 2.
Sure. That's the one you want to go for. Let's do it. So y minus negative 2. What would I write? Y minus negative 2, like that?
Yeah, but
Yeah.
just put plus. I mean.
Okay, so you would have done plus as well. Good. 3 over 2. X minus, and then 2. At this stage, what would you have done, Lisa? Would you have expanded the 3 over 2?
Yeah.
I don't think that's the best way to do it. So maybe a trick you want to learn is when you're given a fraction here, don't expand the fraction for your equations of lines. Expand the 2 to the left-hand side.
Okay.
All right. So you get 2 times y, 2y. 2 times positive 2 is positive 4. Then you expand just the 3. Cool. So that becomes 3x minus 6. And then, of course, you guys can probably see you want everything to one side. So you want it in general form. So 3x minus the 2y, and then minus 6 minus 4 gives me minus 10. So literally all I would write, all I would write at this stage is just rewrite the question out. Equals 0. And all you've done, you've technically moved this over to this side. Lisa, easy?
Yeah.
Good. And last one, find the equation of DC. Okay, so again, what are we going to use to find the equation of DC, Lisa?
Is it the same one?
Same formula, right? That's the only formula you know to find the equation of a line. If you guys remember when we did it in tangents and normals, I did say this formula here is probably going to be the one you'll use the most in year 11 and 12. Because you're going to find equations all the time, and it's going to be this one here. All right, but equation of DC. Well, I already got a point, C, so that's perfect. I don't know that point, so I might as well use C as my point. So my C was -1 and 3. That's my x1 and y1. I need my gradient. And it said something here. What would the gradient be?
That's same.
Same as?
Uh,
Exactly, yeah. 3/2. And what if it said it's perpendicular, Alessandro? What would the gradient be then?
The negative reciprocal.
Which would be? What's the negative reciprocal?
2 on 3.
Done. See, I'm trying to link everything like we did that back in calculus, tangents and normals. You did that. You're doing that again here. So you guys, I hope you start to realize it starts to become pretty repetitive. I really, really hope you start to realize this. Times it by 2. X plus 3. And obviously, again, bring everything to one side. Lisa, what do you reckon? All good?
Yeah.
So
Same.
now yes.
My teacher told us that we have to leave everything in general form. Is that correct? Or can we just leave it
No.
in white?
So it's up, firstly, let's get something clear. This says show. So you have to show whatever it says. And
Yeah.
that was in general form, gradient step form, in any form, you would have had to leave it exactly as it showed, right?
Yes.
So, okay, that's first thing. Second thing, this says find. When it says find, this is the find. You're done. You could have actually stopped there.
Okay.
Cool, that's find. You just found it. There it is. That's an equation. Isn't this the formula for an equation of a line?
Yes.
And you just found it. Finished. But we don't like it like this. We would like to see this line. But to get 4 marks, it's that line right there. You found it. Good job. Now, the general idea with what you just said is this now. If this is a fraction, we generally don't like gradient instep form. So you wouldn't usually see me write this in gradient instep form unless it said show. What I would do is times by my 2, like I showed Lisa, and then bring everything to one side and write it in general form. If this said just 3, then you're not going to see me write it in general form. I'll probably write it as gradient instep form.
All right.
Does that make sense?
Yeah.
But if the question just said find, HSC marking, I mean, your teachers are different, but we're talking about HSC, that's 4 marks right there. Because you found it. And then and the reason why that's 4 marks is because the next part usually is like to use that, and you generally don't need it to be anything else other than pretty much just there. So find the coordinates of D. Well, now you know that that's DC. You found its equation. You know D, the X value is 0. You don't know the Y value. So really, it doesn't matter if you had this equation, or this equation. All 3 are the same. So you could have just subbed it in into the first one. And in fact, Sandra is probably, in hindsight, you can see, because you're going to solve for Y, it would have been better to have it in gradient instep form. But like, how would you know that, So I'm going to sub in X is 0 into this one, just for fun. So we'll go like this. 0 plus 1 is just 1, so that's nothing. And then just add 3. 1.5 plus 3 is 4.5, or 9/2. And that's it. Find the coordinates of D, 0 and 9/2. You subbed it into here, X is 0. You would have got -2y plus 9 equals 0. Bring it over, maybe bring the 2y over. So 9 equals 2y. We've got y equals 9/2. Same thing. Yeah. Good question, and that's the way it works. Any questions? Anyone not sure how I got E? No, we're happy. Good. How many marks was that? 1, 2, 3, 4, 5, 6. Wow. 6 stuff for, well, come on. I don't know. Was that year 9 or year 10? I think it's year 10. Yeah, probably more year 10. Year 9, you would have done rise over run, I think, as gradient. I think. Oh, good. All right, this one. We've done this one a bit before. I think I feel like Eden knows it because she's being very particular with this type of question. So Eden, am I right to say you do know what to do here? Look at this.
That's a circle.
It is a
and
circle. But how, if I had to draw it, what would I need to do to this? I need to do something. Yeah. I thought you would know because you've asked me a few times about this one actually.
I have. Oh, okay.
Maybe
Complete the square.
yes.
Oh, okay.
100% will be in your exams. And I said that when we did it as well. 100% will be in your exams. Complete the square. The reason why it needs to be completed the square is because, Eden, you realize it's a circle. So if it's a circle, you need it to be like this.
Yes.
You know, x something something squared plus y something squared equals r squared. So you got to complete the square. And here we go. X squared. Well, I'll do it slower today than I usually would. I'm going to rearrange this just so we can keep everything in the one place. Constants, though, are always to my right-hand side. That's just the way I've taught it to you guys. Constants, right-hand side. I don't ever want to see a constant on this side. Then, here we go. X minus half this, square it. Y plus half this term, square it. Do we have any questions there from anyone? Someone's just got to go on mute because I don't know who it is. I don't think it's Josh. Maybe Eden. I just hear some stuff in the background. Nice.
Hello.
Yeah, I can hear you. Not me.
Oh.
Yeah, I just hear. Sorry, I've got to put you on mute, Eden. Sorry, I'm going to put you on mute unless you need to talk. I'm only putting you on mute so that I can hear. I think someone's playing around in the background. Maybe it might be your brother, cousins. I don't know. Yeah, sorry. Unless it's not you. Radius. What is the radius of the circle? Radius would be 16 plus 4 is 20. 20 take away 11 is 9. So radius would be, so this equals to 9. Radius would be 3. Square root of 9. Right? Because r squared. So if it's 9, your radius is 3. And we go again, consider the quadratic function. Find the coordinates of the vertex. All right, I'll leave it with you guys for maybe a minute just to think about. There's two ways of finding vertex, isn't there? One is axis of symmetry. The other way is to find your midpoint of intercepts, of x-intercepts. Maybe we should add that. So there's two ways. You pick whatever you're comfortable with. And then draw it. Okay. Find the coordinates of the vertex. Does anyone not understand one of the two methods? So they want me to do it the other way. No, we understand both methods. Let's come back in. 1 take away 2 is -1. So therefore my vertex is 1, -1. Draw a sketch of the quadratic showing the essential features. Y is equal to x minus 2. From that I can tell it's at 0 and at 2. At 1 it's at -1. And I know the y-intercept is at 0 and done. 2 marks.
Sam, how many marks was the whole paper out of again?
80. Feeling confident?
Yeah.
I hope so. Let's go. Let's try this one. Prove sine theta cos theta tan theta equals 1 minus cos squared theta. How do we start this? Prove. Always left-hand side equals right-hand side. Not always, actually, 98%. 2% of the time you use the question. But that's very rare. And you'll see when to use those ones. Left-hand side. Left-hand side is sine theta times cos theta. Tan theta is sine theta on cos theta. What do I do my next line?
Cancel out cos
You're left with
sine theta
Equals?
squared 1 minus cos squared theta.
which equals
Right hand side.
yeah. You're like, what? Right hand side. Yeah, just right hand. You got to do it like that. It's because it's a proof. All right, so you're saying LHS equals this, which equals to RHS. Easy. Right, Eden, again, easy 2 marks. Good. Differentiate. Ooh, sounds familiar. Calculus. So differentiate this. What does y dash equal to? Or dy dx? Or f dash? They're all the same thing. I just want to revise. Who wants to try that? Nice and easy one. Yep. Someone?
Yeah, I'll try.
Go ahead.
So it'd be 3 times. Oh, wait for that one. Oh, jokes.
That's one.
Yeah, 12x minus 1.
Yes, love it. And while you're here, because I really would like to see if you can get this bit out, what
Yeah.
don't you like about this, firstly?
The surd and the x's on the bottom.
Oh, I love it. Thank you. You're saying exactly how I would want to hear it. I don't like surds. I don't like x on the bottom. So let's get rid of the surd first. We'll do it slowly. So that becomes x to the power of 1 over 3. That's how you would write that.
Yeah.
And then that equals to 3x to the power of?
Negative third.
Oh, good man. All right, go ahead, finish it off. Y dash then.
Equals 3 times negative a third, which is just -1.
Yep.
And then it's x
And then use your calculator. I want you to use
negative
I want you
4.
All right, fine. You know it. -4 on 3. I just don't want to see mistakes.
All right.
Negative x, and then that's because it's worth 1 mark. I think that's great. But the way I've taught it to you guys is the way it starts is the way I want it to end. It's a better technique to learn, especially as we get into year 12. So that means that's going to be a -1 stays on the top. Over, this is going to go back down to the bottom as this. And then, of course, this becomes cube root of x to the power of 4. All right. Now you guys can ask me questions from A or B. What do we think? All good? Are we stuck? Lisa, Tiana. Tiana's not here, actually. Lisa, Eden.
It's alright.
It's
No, I
all
think it's
right.
alright.
Why just all right? It's got to be perfect.
Because
Probably try- try to-
I'm. It's
Try to
alright.
get it to
I like-
maybe over 80% before you started at school. Like really go
Yes.
back over it one more time before you start at school, because you know they might confuse you. Just get it to that mark and then be like, okay, I can actually do this. It's more than all right. But what bit confused you the most out of all this? Like that's a rule. Firstly, these are rules. You know, no surds in the bottom and no x's in the bottom. Sorry, no surds and no x's in the bottom. But what about the actual differentiation bit? Are you comfortable with the differentiation? Do you know what we're doing?
Yes.
Okay,
Yeah.
that's the most important bit. So we brought the power down and subtracted 1. That's super important. The rules is something you will just naturally learn and you'll get used to. But yeah, cool. Okay, that's okay. That's all right. This one here. Again, no surds. So I've got to rewrite this like this. And then there's a bit of an issue here. There's also another, stuff in the inside. So Lisa, go. Since you're about to start this at school, let's give you a nice recap. Y dash equals, what are you going to do?
Oh, sorry, my mic was off. Bring the half down.
Bring the half down. There it is. Then
And then you minus 1 from the
yes,
top.
yes. But what do I write? Just what? Minus half?
it's it's
Tell me everything you would write.
4x minus, no, that's it. It's just,
Yeah, see, that's what I was worried about. Okay, so the way it works is this. So if you remember chain rule, and it's okay, it's just because you haven't done many questions just yet, but watch this. Chain rule says this. You actually do everything we normally do. So which is what? You bring the power down, right? You keep the x the same. You see how you didn't say, oh, differentiate x, that becomes 1? Right, you didn't say that here, did you? You just said, I'll keep it the same and then take away 1 from the power. Right? So now, you brought the half down. Keep it the same. So what would you write?
2x squared minus 2.
Good. Then you take away 1 from the power. What would you write?
Minus 302.
Minus half. Sorry, half, take away 1. Plug it into your calculator.
Oh, minus a half.
Minus a half. See, I hope you can get at least to that step. And that step is just your normal step that you're used to. The only extra thing this guy says is you've got to multiply by the derivative of the inside. So now you differentiate the inside, which is what you said. 4a. I think you got that?
Yeah.
So bring the power down. Keep it the same. Take away 1, just like normal. But because there's extra stuff in here that this didn't have, this was just an x, I got to multiply by the derivative of the inside and then just fix it up, I guess. 4 times half is 2. 2x. And then that's good enough for now. For those who want to see it done in a different way, negative half goes down and the denominator is positive half, and then positive half is just square root. So you could write it like that as well. I would prefer this line here, but it's not too much of a worry right now, especially if they're only worth 1 mark. Okay. Next one, this one here. We have to use something for this. Anyone remember the name of that?
I don't know the name of it, but was it the u dash
Yes,
v plus v dash u?
I love it. And it's just called the product rule.
Oh.
Who cares about the name? If you know the formula, who cares about the name? But yeah, product, multiplying. So u v y dash equals u dash. So differentiate this guy, 2x v, leave it the same, plus v dash, differentiate x is just 1, so nothing, times u. All good? You're not here to factorize, so don't factorize. You don't need to factorize it. You don't need to do nothing. You're not here to do any of that. You're just here to differentiate. So don't look at that and be like, oh, okay, we gotta factorize now. Don't do it. Just keep the temptation away. U, V. Lisa, you want to try it one more time? You think you know this one as well?
Yeah, it's the same thing, just with the minus.
You are very close. I like it. That means
Oh,
look,
over v squared.
yes, so just because you're about to start it, your teacher won't say u dash v. Won't, 100%. Your teacher will say v u dash plus u v dash. Can you see mine's exactly the same? I just put u first because this one here specifically has to be u first. So I just link them together so that you can say what you just said. Oh, it's just a Sam with a minus. So don't look at that and be like, oh, Sam, I'm doing it differently now and I've changed. And don't do that. Cool?
Okay.
Okay. Please promise me you will not do that stuff. Just do it before, because you've already memorized it. Why are you going to make it harder on yourself? Okay, so don't really follow your teacher's lines because they'll be the opposite way around. This x minus 4 would have been here. This 2x would have been here. But you do it as u dash v and then plus v dash u. Just be careful. You just do it your way. When you do product rule, just be like, okay, I know this one. You do quotient rule, be like, I know it. The one that your teacher can't change, obviously, is chain rule. So this one, it's fine. Just listen to it. It's not a problem. There's no difference to it. All right, cool. U dash. This one dash is 1. V is 7 minus 3x. Mine is V dash, negative 3. U is just x. See how I use brackets here? I use that because I know there's also a negative here and I don't want to make any mistakes. V squared. And obviously that's why it's worth 2 marks, because there's a negative and a negative. Left-hand side is just 7 take away 3x. The right-hand side of this bit would be plus 3x. These two would pretty much cancel out over 7 take away 3x squared. Easy, 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 easy 2 marks. All right, you guys, any questions about that one? Lisa, what about you? All good with that?
Yeah, all good.
Feeling confident walking into calculus?
For calculus, yeah, sure, but everything else. Oh, God.
Oh, God. Well, that means it's good. Calculus is a good one to know because 5 out of 6 of your topics in year 12 is calculus based. That's good. All right. Your friends, logs and exponentials. Yeah, exactly. That feeling. Tell me, what would I do to both sides? Or if you don't want to do it to both sides, this one's probably a little bit easier. We've got 2 options, just so you know. Or 2 ways of doing this. So option 1 would be change 32 to base 2. So same bases. And that only works if you can do it, which you can't all the time. So only sometimes will work. Sometimes work. If you want something that works all the time, always, it's what? What do you do to both sides?
Do you log it?
Right?
Okay.
Because it's an exponential, the opposite of the exponential would be logging. You log it, yeah, that's it. So ln, both sides. So this looks like this technically. I'll just show you. Log 2 to have 2x minus 1 equals log 32. What am I allowed to do with powers for logs?
You bring them down.
Bring them down. So I get 2x minus 1. Look, something that was really hard to solve for, all of a sudden it's down here. 2x minus 1 times by log 2 equals log 32. Don't forget what you're solving for, x. Lisa, what would you do at this stage for log 2, which you don't like? Either two options again. You're either going to expand or you're going to divide.
Do you just the exponential one?
Whoa, hold on. No, oh, right, that's what you're saying. No need. You will do that. Okay, let's make something clear. I get what you're saying, but try to get this clear. It's really important, and they sound the same, and that's where the confusion comes in. If you want, you can write it up. So this one compared to, sorry. Okay, you ready, Lisa? Listen to the difference in the two questions. How do I get rid of sine? Well, to get rid of sine, you got to do the opposite of what sine is. That's attached to the theta, which is inverse it. So this one here, it would be inverse sine, shift sine. Sounds good?
Yeah.
How do I get rid of sine 40? Well, now you can't say, hey, shift it, because you actually want the 40 degrees with the sine. So what you're looking at is, how are these two attached? Not how are these two attached to get rid of the sine.
Okay, I get it.
Yeah. So how would I get
So
rid of
you
sine?
would just divide by ln2, the 30,
That's
the
logic.
ln32.
Because here, this one here, you are going to do what you said. You are going to exponential these two questions, right? But you got to. It's important to know when you will and when you won't. If I've got a question that says log x, I'm like, I want to get rid of just the log. You're going to say, hey, exponential it. But if I've got log 2, and if I've got, I don't know, x in front of it, let's say, you're going to say, hey, just divide this guy out. That's just a number. Good.
All right.
Good. Really, really important. Very big problem every single year. A lot of students mix this up because they think it's the same. It's not. Good. So yes, you will divide log 2. So you're left with what? 2x minus 1 equals, plug it into your calculator, ln 32 over ln 2. I think it simplifies nicely. ln 32 over ln 2. Yes, it does. Gives you 5 plus the 1. I think we already know the answer, don't we? Plus the 1 is 6, divided by 2 is 3. All good with that?
Yeah.
You haven't even done logs at school, right? That's just from what we've done.
Yeah.
Yeah, see, not bad. So the fact that you guys even said bring this down is good. So when you do it at school, at least you won't be like, what are we doing here? How come this is all working out? But there you go. Look, this one here, you can do it. You could have done 32 as 2 to the power of 5, right? But like I said, it works sometimes. So if I made this into 31, all of a sudden you're screwed with that method. You can't even do that. So the one that you want to really know is obviously logging. If it's an exponential, log both sides. And nice. All right. This one here, log x sub base 3 equals 4. Anyone remember how I can write this one here, log x sub base 3? It was a
Log x
fraction.
on 3.
Say it again, log x on?
Log 3.
Oh, too good. And then you're trying to solve for log x eventually, right? Oh, sorry, you're trying to solve for x. So what would you get rid of next?
You get rid of the log 3
Correct, how?
by multiplying over to the other side.
That's it. So ln x equals 4 log 3. And then what would you do to both sides?
Exponential.
Lisa, does that make sense?
Yes.
So you would exponential because you actually want to get rid of the ln, not the ln3. You want to get rid of the ln, which is the exponential both sides. Plug that into your calculator, please. From my calculator, it gave me a nice answer of 81. Check it out. Make sure you guys still know how to put that in. You press Shift ln. That becomes E with a little box. Your box, you write 4 ln3. I will do that. Ganesh. Let's do it. We'll do axial symmetry soon. Cool. Okay, this one here, pretty much the same thing. So I'm going to write log 4 on log x plus 2 log 8 on log x equals 4. All right. Now what do I do? What would you do if you had a question like this just with x's? Eden, do you want to try it?
Yeah.
Yeah, what would you say?
Could you move them over to the 4?
That's pretty much what you would have done, wouldn't you? If this was an x and an x, you don't like fractions, so you probably would have moved it over. So you would have had log 4 plus 2 log 8 is equal to 4 ln x. Right? And then what I did say is if you do want to exponential, you can't actually have the plus sign there. You don't really want it there. So there's a way to combine these, but to be able to combine these, I can't have a 2 there. So what do I do with the 2?
Divide it.
No. If you divide it by 2, just so you know, if you're divided by 2, it's going to have an over 2, then it's going to have an over 2 as well. And then you just got another problem, which is this one's over 2. So, Andre, did you say it?
Yeah, chuck it on top.
Chuck it on top. It's that simple. Do you remember that rule, Eden?
Okay.
If you've got a number in front, yeah, it's actually the same as power. And then same thing with this. If you really wanted to, you can chuck it on top. Why not? Let's just do it. It won't make a difference. You could have left it and then divided it later, or you could have chucked it on top. But to keep everything uniform, why not? What do we do when we plus logs, Eden? Think of index plussing. When did you plus indices?
When they had similar bases.
And you were multiplying them, right?
Yes.
But you multiplied the bases, so you added the powers. So if you're adding logs, it's the same as multiplying the insides. So that becomes log of 4 times 64. You get that?
Oh, okay. Okay.
64 is just 8 squared. And then at this stage, what would you do to both sides?
Exponential.
Correct? Or you could have just crossed out your logs. It's up to you. But exponential, these would have cancelled out. ELN just cancels out. So you're left with 4 times 64, which is 256 equals x to the power of 4. And then how would you get rid of the power of 4?
Root it by 4.
Yep, so fourth root. Fourth root of 256. Make sure you're able to do that in your calculator. You press
Would that be
shift.
plus minus?
Ooh, good point. You are correct, right? I'm going to say yes to plus minus 4. I would have completely missed that. Good job. But anyways, yes to plus minus 4. But can we log negative 4?
No.
Do you remember why we can't? Do you remember the graph of the log? Looks something like that.
It doesn't go into the negative.
It doesn't go
region.
0 and it doesn't go into the negatives. So you can't log a negative.
Okay.
But good, yes. Like if it was any other question in the world, yes, you are right. So I won't take that away from you. That was good. Good job. Okay. Right. All right. And again, you can see the questions that you pretty much get in your exams are the questions that we went through. You don't need 1,000. What you need is just this exam paper and just to keep going over the same questions over and over again until you're able to execute every single one of them perfectly. So my first one started off at 20-30%. Then I did the exact same one again until I got it to 50%. I did the same one until I got to 70. So I kept making the same mistakes. And then eventually when I got it to 100, I moved on to another paper. So you guys can see the questions are pretty much stock standard. Nothing amazing. But you've got to sit down and discipline yourself to get them to 100%. I think we did this one last week. For values of d, does this equation have no real roots? We did do this last week, didn't we? Rings a bell to me. No real roots. What do we remember? The discriminant must be
Less than 0.
less than 0. No real roots, less than 0. The discriminant is b squared minus 4ac must be less than 0. B squared. So d take away 6 squared minus 4 times a times c, which is 1 times 1, less than 0. Expand and simplify, I guess. I'm going to cheat a bit here. And I'm not going to expand just because I can see what I can do a lot easier. But you could have expanded and then solved, just so you guys know. Okay, there's always going to be 2 or 3 methods, and it's not a problem. I'm going to do this. So you guys know for less than 0, I always make it into an equal sign. I would plus the 4 over. I'm going to plus minus square root of 4, which means I get d take away 6 equals plus minus 2. And then d equals to 6 plus minus 2. That's probably the quickest way you could do that. If you didn't see that, then you would have to expand and simplify. So d equals 8, and 6 take away 2 is 4. I would draw on a number line. There is 4. There is 8. They're both open circles because they're less thans. And then what do we do at this stage?
Check it.
Check, test, whatever you're doing. I'm going to check 0. So check d equals 0. Sub it into the original. 0 take away 6 squared, take away 4. Is that less than 0? That's 6, 36. 36 take away 4. Is 36 take away 4 less than 0? No. That means 0 does not work, which means they're not running away. They're not going this way and this way. They're going to meet. The answer is 4 less than x less than 8. Do we need more work on this? I feel like we need a bit more work on this. What do we think? Or no, we're pretty comfortable with that. That makes a lot of sense, and that's pretty much what you would have done. Sandra, what do you think?
I'm fine.
Not sure?
No, I said I'm fine.
You're fine? Okay, cool. For sure. Yep. Lisa, Eden, what do we think?
Yeah, I probably would have got there maybe.
Where do you feel like you would have got stuck?
The
solving
no real root part.
Okay, yeah, just at the beginning. I thought so. That is actually probably the most common area that everyone gets stuck at. No real root means no solution. If it's got no solution, what does it mean about your discriminant? It's got to be less than 0. If you had one solution, that means your discriminant had to equal to 0. If you had 2 solutions, your discriminant has to be greater than 0.
Right.
Did we not go through this last week, like I said? Maybe it was
I think we did, but I just haven't remembered.
Okay, well, let's go through it again. It's okay. Let's just to make sure. So in your quadratic formula, you've got this. Now this pretty much tells you usually you're going to have 2 solutions, right?
Mm-hmm.
usually. The problem is you don't always have two solutions, because if b squared take away 4ac was 0, therefore you're going to get minus b plus minus 0 over 2a. You're actually only going to get one solution, the negative b over 2a, which is the axis of symmetry. So what they've learned is that the discriminant, which is b squared take away 4ac, you get that, right? The discriminant is b squared take away 4ac.
Yeah.
If that was equal to 0, then this bit here is equal to 0, which means you'll only have x equals one solution. You don't have plus minus anything else. That makes sense?
Yes.
And if you, what if that bit there, the inside was negative? What if it was a negative number? What's the square root of a negative?
Nothing.
What's the square root of negative 5? Not only nothing, because nothing is 0. It's math error. There is no solution to it.
Okay, good, because I was going to say that, but I wasn't sure.
Yeah, no solution. So 0 solutions. But the better answer would be no real roots. No real roots. No roots. There's no solutions. Roots are just intercepts, by the way. So these are called roots, intercepts, or even solutions. All three are used interchangeably. And of course, what if you got delta, or the discriminant, sorry, is greater than 0? What if that number was 5? Well, how many answers are you going to get now for x?
2.
You get 2 solutions, 2 roots, and so on.
Okay.
That's it. And then when it says, oh, it has 2 roots, you're just going to use that formula. Find, you know, when it says no solution, like the one we just did, we use that one. So you go up, and it said, the question said, find whatever has no real roots. Oh, yeah, okay, discriminant less than 0. So let me go and solve. We found it, subbed it in, and it's got to be between 4 and 8. As long as as long as D is between 4 and 8, this equation will have no solution ever. Does that make sense?
Yeah.
If it's 9, it might have a solution. We're not sure. We didn't test for that. But if it's between 4 and 8, it will definitely have no solution. Okay, good. 100% will be in your exam. One of them, one of the 3. You're not sure which one, but will be in your exam.
All right. Cool.
So you want to master that a little bit. Okay, applications of logs and exponentials. Oh, what? And we're done. Oh, we're literally there. Look, a 2-hour paper, if you're pretty much ready, should be done in an hour, hour and a half. I can tell you that if I can tell you what the extension kids will get this done in, or should get it done in, let's rephrase that, should. If it's a 2-hour paper, usually they get it done in half of the time. So they've got to get it done in 1 hour. So that means you guys are the same thing. If it's a 2-hour paper, you've got to try to aim for it to get done in an hour, but I usually give the leeway of an extra 15 to 20 minutes. An hour, 15 minutes is good. You need to be able to get it down to that limit so that you've got another 45 minutes to go through the whole thing. And obviously that's how you'll get close to 100%, because you get to go through it a second time, you pick up any silly mistakes. But yeah, cool. Let's have a look at these last 2 questions. Question 33. The number of frogs in a park at time t is given by this formula, where n0 and k are constants. This is k, by the way, or meant to be k. Initially, there were 100 frogs in the park. Initially, there were 100 frogs in the park. What is the value of n naught? What does initially mean for time?
Like the start, so 0.
Yes, fantastic. Time is 0. And what does n equal to? The number of frogs? 100. Come on. You've got to agree. That was easy, 1 mark, right? E to the power of, this will be just 0 because you said time is 0. E to the 0 is 1. So n0 is 100. Lisa, what do you reckon? All good?
Yep.
All right. How many frogs were in the park after 10 weeks? Oh, come on. Are you serious? That's even a question. N equals, but the truth is these are the exam questions. These are straight from Year 12 HSC. These got brought down because it was too easy for Year 12. But that is actually the style of question. E 0.3466. And then the only thing I've got to teach you guys to go back and check. T was in weeks. Please be careful. This is still in 10 weeks. But imagine this said T, I don't know, days. And it said T 10 weeks. You have to sub in 70 for that because T is in days. All right? Do we get that? Otherwise, this one's just T is 10 weeks. Can we please get the answer correct to 2 sig figs? Let's make sure we're all able to do that in our calculator. I got 3,200.
Yeah.
Yep.
Same.
Eden, happy as well? Good. Okay. Last one.
Okay.
Find the rate of increase. Rate. Anyone know what rate means in this context? Or can remember what it meant? We didn't actually. Sorry, we didn't do this, did we? No. Not for you guys just yet. I left differentiation of exponentials. I did not do the rate bit yet because so I did not do that. Leave that. Sorry. Question 34. Evaluate the following limits. All right. Very easy. What do I do for the first one?
Sub in 4.
Literally, if you can sub in, the trick was, excuse me, if you can sub in 4, then sub in 4. If you can't, let's just say if it was like that, 1/16, take away 16 is 0, and 1/0 is a problem, then there would have been something on the top to cancel it out. But in this case, just sub in 4. It's just 0, 16 take away 16. Last one, sub in 5, just check the bottom. Make sure you can sub in 5. So let's sub in 5 into the bottom first. The problem is a lot of students would have subbed in 5 here and gone, oh yeah, 5 take away 5 is 0. 0 divided by anything is 0, right? The problem is 0 divided by anything is 0, except 0 divided by 0. 0 divided by 0 is not 0. And when you do sub in 5, did you guys realize? Did you guys see that the bottom gave you 5? I gave you 0. Sorry.
Yeah.
Yep. So we've got to actually eliminate that. So that means we've got to do a bit of factorization. So the bottom, you already know it's just going to be x minus 5 because you know it's got to cancel out. That's the trick. This one's going to be, if I can do it quickly and cheat a little bit, this one's going to be that. Let me make sure. 2x squared, yep, plus x minus 10. 1x take away 10 is -9. -5 times 1 is -5. Brilliant. Then these two cancel out. You're left with limit. Look, until you sub it in, you've got to keep it the same. 1/2x plus 1. And then sub in 5. 2 times 5 is 10. 10 plus 1 is 11. The actual answer is 1/11. All right. What do we think? How do we feel? another example
Okay.
as well.
Look through calculus again.
Yeah, that's fair enough.